engineers, welcome to my YouTube channel. If you are still new to my channel, please don't forget to subscribe so that you will be updated with my future videos, which might be beneficial and helpful to your studies. And I hope that my videos will serve as your alternative video for you to understand the principles on the different subjects in civil engineering. So here we go. For the frame shown below, construct the shear and moment diagrams. Also sketch the elastic curve. So we have the frame here, and this length is 8.5 square root of 4 square plus 7.5 square. The horizontal component of force is 3.6 times 7.5, 27. The vertical component of load is downward 3.6 times 4, horizontal projection. And it acts, 27 acts 3.75 or half of 7.5 meters above A and 3.75 below A. 14.4 kilonewtons is acting 2 meters right of A and 2 meters left of A. So the component reactions, AH leftward, AV upward, then RD. Summation moment about A equals 0. Counterclockwise positive. So we have R sub D times 15 minus 27 times 3.75 minus 14.4 times 2 minus 6 times 5 times 9.5 minus 9 times 13.5 equals 0. So R sub D is 35.77. So R sub D is 35.77 kilonewtons. So AH summation forces horizontal is 27 kilonewtons leftward. Of course, it's obvious in the figure. Then let's have summation moment about D equals 0, clockwise positive. So we have AV times 15 plus 27 times 3.5. This AH here, 27 times 3.5, that's 3.5 plus 27 times 0.25, because 4 minus 3.75 is 0.25. Then minus 14.4 times 13 minus 6 times 5 times 5.5. Then minus 9 times 1.5 equals 0. So A vertical is equal to 17.63 kilonewtons upward. Now let's resolve the AH and AV as perpendicular to the member AB and normal to the cross-section of AB. So remember, this is theta and the slope is 7.5 times 2, so 15 vertical, 4 times 2, 8 horizontal, and 17 hypotenuse. So this is the AH, then we have AV, and this is the component perpendicular to member AB and normal to member AB. So this is also theta. So from the figure, VA is, so component of 17.63 is going there. So it is 17.63 cosine of theta. And since this is also theta, so plus 27 sine of theta, opposite of theta. So VA is 17.63 cosine of theta plus 27 sine of theta. Cosine theta is 8 over 17, sine theta is 15 over 17. So VA, or the shear at A, is equal to 32.12 kilonewtons. Then NA, 17.63 sine of theta, so times 15 over 17 minus 27, because component of 27 is in this direction. So minus 27 times cosine of theta, which is 8 over 17. So NA equals 2.85 kilonewtons. Then let's have on the other side, RD is vertical, then this is called the theta 1, this is also theta 1. Opposite of theta 1 is 4, adjacent is 3, hypotenuse is 5. Then this is 35.77, which is RD. Then we resolve that into perpendicular to CD, or the shear force in CD, and the normal to CD. So the perpendicular to CD, or the shear force, is 35.77. This is 90 minus theta 1. So this is theta 1. So it is 35.77 cosine of theta 1, which is 3/5. So 35.77 times 3/5. So shear D is 21.462 kilonewtons, while normal is 35.77 sine of theta 1 opposite, which is equal to that. So 35.77 times sine of theta 1 is 4/5. So ND is 28.616 kilonewtons. Then we have here member AB. These are the components of shear and normal. So since there's no other normal, if we apply the original load, this is perpendicular to the member, 3.6 times 8.5, which is equal to 3.6 times 8.5 is 30.6. Then summation forces along this axis here is 0, so this must also be 2.85 opposite to this. Then summation forces perpendicular to the axis of the member, 32.12 is greater than 30.6, so therefore the shear at this end at B is going down. 32.12 minus 30.6 is 1.52. Then let's have this element here. The moment, by the way, is, let's assume, counterclockwise opposite to this moment. So there are two ways to solve for the moment at B. It's 32.12 times 8.5 minus 30.6 times 4.25, half of 8.25. Or the other way, based on this figure here, it is AH 27 times 7.5 plus AB, which is 17.63 times 4, then minus 30.6 times 4.85. So this is counterclockwise. So next is clockwise, action-reaction principle. Then we have NB here, then going down, shear at B. Then the moment is now counterclockwise because this is clockwise. So moment at B is either 32.12 times 8.5 minus 30.6 times 4.25, or 27 times 7.5 plus 17.63 times 4, then minus, going back to this load, 30.6 times 4.25. So they are equal. MB is equal to 142.97 kilonewton meter. Then NB from here is like summation versus horizontal. So NB is equal to 2.85 cosine of theta, cosine of this angle theta, so up to the right. So 2.85 times 8/17 minus 1.52 times sine of theta, which is 15/17. So NB is equal to 0. So that's 0 expectedly. Vis-a-vis is the sum of the vertical components of these forces. So 2.85 times 15/17 plus 1.52 times 8/17. Because both are upward and vis-a-vis is downward. So vis-a-vis is equal to 3.23 kilonewtons. Then this is NB, as I said. Then for this member BC here, we have to transmit NB, which is 0, by the way. Vis-a-vis, which is now upward. And at C, V sub C. So MB is now clockwise. Then V sub C, N sub C, MB, and N sub C. So from this member here, we transmit V sub D equals 21.462. ND is 28.616. Then that's the load. Then here in CR, VCR, and moment about C. Slope 3, 4, and 5. So this is also theta 1. So for the value, let's transmit here NCR, then VCR up to the right, then N sub C to the right, then V sub C downward. So N sub CR is equal to ND, which is 28.616. It's like summation forces along this axis here. So NCR plus 9 sine of theta 1 equals ND. So NCR is ND, which is 28.616 minus 9 sine of theta 1. And sine theta 1 is 4/5. So 9 times 4/5. So ND is 21.416 kilonewtons. While VCR is V sub D. V sub D is 21.462. Then minus the component of 9 perpendicular to the member, which is 9 cosine theta 1, and cosine theta 1 is 3/5. So V sub D minus 9 times 3/5 is 16.062 kilonewtons. So next, we concentrate here to solve for VCR and NC. V sub C is equal to the upward components of these two. So VCR times cosine of theta, because the angle theta is the angle between the vertical and this VCR here. So it is cosine theta. Then plus NCR times sine of theta. So NCR is 21.416 times sine theta 4/5. So V sub C is equal to 26.77 kilonewtons. Or the other way, for computing V sub C, it is equal to 35.77 minus 9 if you consider the entire free body diagram of CD. So that's the shorter and simpler way. So next, N sub C is equal to V sub C. It is equal to N sub CR times cosine, this is theta, N sub CR times sine of theta. NCR, N sub C is rightward plus N sub CR so N sub C plus V sub CR sine of theta. V sub CR is 16.0062 sine of theta. This is this. So N sub C is, because N sub C is rightward, so 16.062 times sine theta minus NCR times cosine of theta, which is 3/5. So N sub C is 0. Then finally, M sub C is either V sub D times 5 minus 9 cosine theta 1, or 9 times 3/5 times 2.5. Or the other way, it is RD 35.77 times 3, then minus 9 times 1.5. That's the shorter way. So for MC, 35.77 times 3 minus 9 times 1.5. That's the easier way. Or I want you to compute the other way, which is V sub D, 21.462 times 5, then minus 9 times 1.5, or 9 cosine of theta 1, 9 times 3/5 times 2.5. So the result should be the same, 93.81 kilonewton meter. So let us now construct the shear diagram and then the moment diagram. So this is the shear diagram. Remember, the shear here is 32.12. Then minus 3.6 times 8.5, and you will have there 1.52. And minus the shear, which is 1.52, that closes. Then here we have V sub D, which is upward, equal to 3.23. You look at the calculations in the preceding slides. Then constant up to here. Then minus 6 times 5, minus 30, 26, negative 26.77. Then plus shear at C, which is 26.77, so that closes. And B sub C here is negative 16.062. Then there's no load, so it's just constant up to here. Then minus negative 16.062 minus 9 times cosine of theta 1, 9 times 3/5, 9 times 0.6, so minus 5.4 is negative 21.4062. Negative 21.462. Then constant again, and that closes because the shear at D is 21.462. So that's the shear diagram. Then here is the moment diagram. The moment here is 0, and we have positive area. Positive decreasing means like that. So area is 1/2 of 32.12 plus 1.52 times 8.5. That's 8.5, area 1. We'll call this distance x1 up to 0 shear. Then this is 2.5, half of 5. So note, outside faces of frame are the top fibers. So area 1 is 1/2 of quantity 32.12 plus 1.52 times 8.5, 142.97 kilonewtons. So remember the moment at B, 142.97 kilonewtons. Then here we have 142.97, the starting moment, then plus 3.23 times 3, so straight line up. Area 2 is 3.23 times 3, so 9.69 plus 142.97, so 152.66. Then let's solve for that x sub 1. X sub 1, the shortcut is 3.23 divided by 6, the loading. So area 3 therefore is 1/2 of x sub 1 times 3.23, and 3.23 minus 6x, or x1 is 3.23 over 6, as I said, or shear equation is 3.23 minus 6 times x1 equals 0 shear. So x1 equals 0.5383 meters. Then area 3 is 1/2 of 0.5383 times 3.23, so it is equal to 0.8694 kilonewton meter. So that we add it here, 152.66. So that's positive decreasing. So positive decreasing, this is the maximum moment, positive moment. 152.66 plus 0.8694 is equal to 153.53. And minus this area, which is area 4. So that's negative 1/2 of 5 minus x1 times negative 26.77. So that's area 4 equals negative 59.52. So 153.53, it's negative increasing, so that's the curve, minus 59.72 is equal to 93.81, which is the moment at C. And 0 here, and we have 93.81 again, minus 2.5 times negative 16.062. So 93.1, that's negative straight line. 93.81 minus 2.5 times 16.062 is equal to area 5. So negative 16.062 times 2.5, negative 40.155. So that would be 53.655. And finally, minus this last area here, which is 2.5 times 21.462, area 6. Negative 21.462 times 2.5. So it is negative 53.655 plus 53.655 straight line, that's 0. So this is the moment diagram. And the elastic curve, so we have concave up somewhere here, concave up, and concave up. But these should be displaced to the right because that's a ruler. So all are concave upward elastic curve because the moments are all positive. So that's it for the solution to this problem.